Okay, so I am recording at this point. So if you talk, you're going to get recorded, just so you know. Um, so in section 9.1, we're going to be looking at prisms. Okay. So a prism is a solid figure having at least one pair of parallel surfaces that create a uniform cross section. The figure below left is a horizontal prism. So if you I'm sorry, a hexagonal prism. This is a hexagonal prism. So if you look at this, again, we have, if you look at this definition, at least one pair of parallel surfaces. So like the top and the bottom are parallel surfaces in this hexagonal prism. Now it's called a hexagonal prism because the top and the bottom, if you were to like slice through there, that forms a hexagon. Okay, does that make sense? Cutting the prism anywhere parallel to the hexagonal surfaces produces the same hexagonal cross section. All the polygons that form the prism are called the faces. Okay, so if you look, if this is a regular hexagon shape, then you've got 6 different rectangles on the sides that are making faces. Okay, and then you have the top and the bottom hexagons that are also faces. Okay, so altogether there are 8 faces to this hexagonal polygon. Okay, so the faces that create the uniform cross section are called the bases. Okay, so like the top hexagon and the bottom hexagon are called the bases. Okay, and then they give the prism its name. The other are called the lateral faces. So this has, in this particular case, 6 different lateral faces, like 3 here in the front and then 3 in the back. Okay. The sides of the polygons are called the edges of the prism. So if you look here, like this is an edge, that's an edge. Okay. And the corners are called the vertices. So like any of those corner points is a vertex, and the plural of that is vertices. And the perpendicular distance between the bases is called the altitude or the height. Okay, that makes sense. So from down here to down here, so essentially the length of one of the lateral faces is the altitude or the height. Okay, any questions about that? A right prism has lateral edges that are perpendicular to the bases and lateral faces that are rectangles. Okay, so if this is a right prism, then the faces here are rectangles, and again, the lateral faces are perpendicular to the bases. Okay, does that make sense? Okay, for a rectangular prism, all opposite faces are parallel, so any pair can be chosen as bases. Every face is a rectangle, and the angles at all vertices are right angles. Now, again, we're talking about comparing the bases to the lateral faces. Does that make sense? Okay, so all the lateral faces are going to be rectangles, but the bases don't have to be rectangles. Okay. The figure below right is a rectangular prism. Rectangular prisms are the most common solids in practical work. So this right here is a rectangular prism. Okay. Now these are right prisms. But this is a triangular right prism, whereas this is a rectangular prism. Okay. A rectangular prism is like a box. Okay. Now, these are not right prisms because we don't have a 90-degree angle with the lateral faces and the bases, right? This is kind of skewed, like it's lopsided box, okay? And this is lopsided, right? Like a leaning tower, okay, or whatever, okay? So here we have, again, a rectangular prism. A cube is a rectangular prism in which all edges are the same length. So if you look here, we have a cube. All of the edges are the same length. So in other words, a cube is made up of squares. Okay, so it's like it's a rectangular prism where all the faces are squares. Okay, and all of those squares are the same size, including the bases. So the top and the bottom and the lateral faces are all the same square. Okay. A triangular prism has bases that are identical triangles. So the figure below center and below right are triangular prisms. So if you look here, we got like the base and the base, they're triangles, and we have an altitude here, it's right, so that is a triangular right prism. Okay, this one is too, except it's laying on its side. Okay, any questions? A trapezoidal prism has bases that are identical trapezoids. The figures below are trapezoidal prisms. So you can see you got a trapezoid on the bottom, a trapezoid on the top, or if you lay it on its side, then the two bases are on the sides there and you got a trapezoid shape. Okay. We know that the trapezoids and not the other faces are the bases, because cutting the prism anywhere parallel to the trapezoid faces produces another trapezoidal prism. Okay, so like if I slice through this, I'm going to get the same trapezoids is the idea. Okay. Three important quantities that can be calculated for any prism are the lateral surface area, the total surface area, and the volume. The lateral surface area, which we're going to denote by a capital L, is the area of all the surfaces excluding the bases. So we had the lateral faces. If we find the area of all the lateral faces and add those up, that's the lateral surface area. Does that make sense? Okay. The total surface area, which we're going to call T, is the lateral surface area plus the area of the two bases. So if I do the areas of all of the sides, and then if I also find the area of the top and the bottom, the bases, and add that all up, that's the total surface area. Okay. In some application problems, we will need to know the total surface area. In other application problems, we'll only need to know the lateral surface area. That's why we need to find those differently. Okay. The volume, or the capacity of a prism, is the total amount of space inside it. Volume is measured in cubic units. The following formulas apply to all right prisms. Okay, so again, if we're talking about volume, then we're going to measure volume in terms of cubic units. Okay. So we would be seeing how many of these cubes would it take to fill up the insides of this prism. Does that make sense? So volume is generally going to be measured in terms of like cubic inches, cubic centimeters, cubic feet, cubic meters, that kind of thing. Okay. Does that make sense? Now, we can also measure volume like of liquid capacity. Like, you know, when you measure like milk, you measure that in like gallons, right? Or maybe like pints or cups, okay? We could also use like liters and those kinds of things, right? So we're going to be able to convert between like cubic units and units like gallons and pints and liters and milliliters and centiliters and so on, okay? Any questions about that? So for any right prism, the lateral surface area, L, is going to equal P times H. Now, what's P? P is the perimeter of the base. So if we find the perimeter of the base and multiply that by the height, the altitude, that will give us the lateral surface area. Does that make sense? Okay. The total surface area is going to be the lateral surface area plus the area of the bases. So the area of the top base, whatever that is, and the area of the bottom base is going to be the same thing. So two of those. Does that make sense? So depending on the shape, that's going to affect how you find the perimeter, and that's going to affect how you find the area of the base. Does that make sense? But otherwise, the formula is pretty general there, okay? The volume will equal A, which is the area of the base, times H, the altitude, the height, okay? So again, if it's like in this case, this figure's a regular pentagon, so how you find the area of that would be different than if it was a square, for example. Okay, does that make sense? But whatever the shape is, if you can find the area of it, take it times the altitude, and that'll give you the height. Okay, so far so good? So example, for the figure shown to the right, find the lateral surface area, the total surface area, and the volume. Okay, so we want to find all three of these. Now, the figure that we have here is a triangular prism, okay? So in fact, it is a right triangular prism, okay? So if you look at the base is this right triangle, which has 6 inches here and 8 inches here. We don't know the hypotenuse of the right triangle, but we don't need to know the height. Well, actually, we do need to know that, and we are given that. That's 10. Okay, so never mind. So 6, 8, 10. Okay, and that is a right triangle, by the way. If we did like the Pythagorean theorem, the two legs are 6 and 8, and the hypotenuse is 10. So 6 squared plus 8 squared is 100. 10 squared is 100. So a squared plus b squared does equal c squared. And so it is a right triangle there. Does that make sense? Okay. So if I want to find the lateral surface area, I need to find the perimeter of the triangle. Okay. So the perimeter of the triangle is going to be 6 inches plus 8 inches plus 10 inches, which is 24 inches. So the lateral surface area, L, is going to equal the perimeter times the altitude. So that's going to be 24 inches times the altitude. I didn't write it down, but that's 15 inches over here. So 24 times 15 is 360. Now this is area, and you know, all of these measurements of the edges are in inches, so my area is going to be in square inches. Make sense? Is that too horrible? So in B, we want to find the total surface area. Well, the total surface area, which we're going to call T, is equal to the lateral surface area plus 2 times the area of the bases. Now, the area of the bases, again, in this case, the base is a right triangle. It's 6 inches by 8 inches by 10 inches. So if you'll remember, to find the area of a triangle, we had lots of different ways that we could do that, but the most basic one is 1/2 base times height. So my base would be 6 and my height would be 8. So A, the area of the triangle, is 1/2 times 6 times 8. 1/2 of 6 is 3. 3 times 8's 24. So the bases have area of 24 square inches each. Does that make sense? So my lateral surface area is 360 square inches. And then the top base and the bottom base are both 24 square inches. So 2 times 24 square inches. Now 2 times 24 is 48. And 360 plus 48 is going to be 408 square inches. Everybody okay with that? The volume. The volume is going to equal the area of the base times the altitude, the height. We just found that the area of the base was 24. By the way, that's 24 square inches. And so if I multiply that by the height, which is 15 inches, notice that square inches times inches will be cubic inches, okay? And 24 times 15, that's 360. So that's going to be 360 cubic inches. Does that make sense? Now, in this particular example that I picked, the lateral surface area and the volume were both 360. That's just coincidental that they happen to come up to be the same thing. That's not normally going to be the case. But even if that was always the case, again, which it's not, this is square inches because it's area, and this is cubic inches because it's volume. So there's always at least that difference. Volume will always be cubic units, and lateral surface area and total surface area will always be square units. Okay. Example 2. For each figure shown, find the lateral surface area, the total surface area, and the volume. Okay, so we're going to find all three for all three parts. Okay, so I've got a rectangular prism, I've got a triangular prism, and I've got a trapezoidal prism. Now this trapezoidal prism's laying on its side. Okay, so we got to think of that kind of more in terms of standing up. Okay, so far so good. So first of all, notice that like on my first figure, the bases are going to be rectangles that are 2 yards or 3 yards by 2 yards. Does that make sense? So I'm going to think of that as my base is this rectangle that's 3 yards by 2 yards. Is that okay? So the perimeter of that's going to be 3 plus 2 plus 3 plus 2. Okay. So the perimeter of that base is going to equal 10 yards. Does that make sense? 3 plus 2 plus 3 plus 2. 5 plus 5 is 10. The area of that base is going to be 3 yards times 2 yards. So that's going to be 6 square yards. You with me? If I find those two things first, then that makes the rest of my work a little easier. Okay. So again, if I want to find the lateral surface area, that's just the perimeter times the height. The total surface area is the lateral area plus 2 times the base areas. And then the volume is just the base area times the height. Okay. So my lateral surface area for part A is perimeter times height, and the height's 4.5 yards. Okay. So that's going to be 10 yards times 4.5 yards. Now I'm going to punch that in my calculator, and I'm going to use 4.5. So 10 yards times 4.5 yards is 45 square yards. So the lateral surface area is 45 square yards. And again, the lateral surface area is going to be the total, is the area of the 4 lateral faces. Does that make sense? Okay. So I've got these 4 rectangles around the sides, if you will, and so that is the lateral surface area. Now my total surface area is again my lateral surface area plus 2 times the base area. So that's going to equal 45 square yards plus 2 times 6 square yards. And 6 because, again, that was the area of the base rectangles. So 2 times 6 is 12, and 12 plus 45 is 57. So that is 57 square yards. Piece of cake. The volume is the area of the base times the height. The area of the base we know is 6 yards, 6 square yards, I should say. And we know the height is 4.5 yards. So if I take 6 times 4.5, that's 27. So that's going to be 27 cubic yards. Again, it's cubic yards primarily because it's volume, but you can also think of that as square yards times yards is going to be cubic yards. Piece of cake. So not too horrible? Okay. So what about part B? Should I give myself a little more room? So in part B, we have well, no, it's not a right triangle. We have this triangle shape here. What do I know here? I know I got a right angle there, and this is 9 inches. And oh, I'm given the height is 5 inches. So I was thinking that was the side, but that's the height that I'm given. Okay, does that make sense? So, so wait a second. Am I going to be able to find the perimeter? Oh, that's given down here at the bottom. Okay, so this down here is 12 inches, and this side over here is 6 3/4 inches. Okay. And again, that's 9. That doesn't look like a 9, but you with me? Okay. Now that's not necessarily a right triangle, but I know the base and the height of the triangle, and I know the 3 sides of the triangle, so I can find the perimeter and I can find the area both. Okay. So the perimeter of that triangle is going to just be 12 inches plus 9 inches plus 6 3/4 inches. So 12 plus 9 plus 6 3/4 is the same as 6.75. So that's 27.75 inches. Is that okay? The area of the base triangle is 1/2 times the base, which is 12 inches, times the height, which is 5 inches. So half of 12 is 6, and 6 times 5 is 30. So that's going to be 30 square inches. So again, I recommend finding those 2 things first. And then once you know those 2, it makes finding the other 3 things pretty straightforward. So my lateral surface area for this is going to be the perimeter times the height, which in this case is, I'm going to write it down here, 27.75 inches times the height is 15 inches. Again, I'm going to write that down here. So if I take 27.75 times 15, that's 416.25. And it'll be square inches again, primarily because it is area, but again, inches times inches is going to give you square inches. Okay. So there's my lateral surface area. The total surface area, well, that's going to equal the area of the of the, or no, it's not. That's going to equal the lateral surface area is what I mean to say, plus the area of the bases times 2. So lateral surface area plus 2 times the area of the bases. Okay. So in this case, that's 416.25 plus 2 times the 27.75. Now, I didn't write the units this time, but this would be square inches. This would be square inches. So when I add them together, it's still going to be square inches. Okay. Well, 2 times 27.75 is 55.5. And if I add 416.25 plus 55.5, that is 471.75. So the total surface area of this triangular prism is 471.75 square inches. And last but not least, the volume, again, that's the area of the base times the height. So in this case, that's going to be 30 square inches times 15 inches. 30 times 15 is going to be 450. So that is 450 cubic inches. Again, primarily it's cubic inches because it's volume, but square inches times inches is going to give us cubic inches. Is B really any harder than A? Not really. Once you know the area and the perimeter, it's not really any different. Okay, they're all the same. So maybe it's a little more challenging to find the area of a triangle than it is the area of a rectangle, or same for a perimeter. But once you know that, it's the same. So is C going to be any harder? Only in that our bases are trapezoids. Okay. So in this particular case, again, this figure is like on its side. Okay. So our bases are trapezoids. And I'm going to look at the trapezoid this way. So I've got this kind of a shape of a trapezoid. Okay. So the way I've got this is these are like right here. Does that make sense? Okay. So this is 16 meters. And then what else do I know? I know this short side up here is 6 meters. I know the longer side down here is 18 meters. And I know the slanted side is 20 meters because they told me that. Okay. So the perimeter of that trapezoid is just going to be those 4 things added up. So it's just going to be 6 plus 16 plus 18 plus 20. And all of those are meters. So it's going to be meters. Okay. So 6 plus 16 plus 18 plus 20. So that is 60 meters. Still with me? Remember how to find the area of a trapezoid? We had a couple of different formulas. You take 1/2 times the height times the sum of the 2 bases. Okay, you with me? And the 2 bases on a trapezoid in this case are the 2 parallel sides. So the 6 and the 18. Okay, the height's the 16. Okay, so the area of the trapezoid is going to be 16, that's the height, divided by 2. And then I'm going to multiply that by 6 plus 18. And if you wanted, you could take 6 plus 18, divide that by 2, and then multiply by 16. That's up to you. Okay. One way or the other, figure out what the area is. Okay. So 16 divided by 2 is 8. And 16 plus 8, I'm sorry, and 6 plus 18 is 24. So I have 8 times 24, which is 192. and the units are square meters. Make sense? So my lateral surface area is going to be the perimeter times the height. Now, in this case, the height, if we stood this up, the height is going to be the 14 meters. So I'm going to write that down too. The height equals 14 meters. Okay. So my perimeter is 60 meters times the height, 14 meters. And 60 times 14 is 840. Does that make sense? Total surface area, again, is just going to be the lateral surface area plus 2 times the base area. Well, we just found the lateral surface area is 840 square meters. We know the base area is 192, so plus 2 times 192 square meters. Now 2 times 192, that's 384, and 384 plus 840 is 1224. So 1,224 square meters is the total surface area. Makes sense? Volume is the area of the base times the altitude, the height. So in this case, the area of the base is 192. Again, that's really square meters. The height is 14 meters. So 192 times 14 is 2,688, and it's cubic meters. So again, maybe a little more challenging up front to figure out the perimeter and the area of the trapezoid. But once you know those, you find the other 3 things the same way that you do the easier ones. Okay. So again, my advice, figure out the perimeter of the base, figure out the area of the base. Once you know those, the rest of those calculations are pretty straightforward. Okay, so I think we're going to do cubes and then we'll call it a day. Okay, even though we might get done a few minutes early, we'll call it a day. Because I won't have time to get all the way through the next part. Okay, so all edges of a cube are the same length, so that the formulas for L, T, and V, so the lateral surface area, the total surface area, and the volume for cubes simplifies as follows. So y'all know what a cube is, right? Okay, so again, we talked about that. So basically you've got 6 squares making up this rectangular prism. Okay, so again, that's called a cube. So the lateral surface area becomes 4 times s squared. Okay, now the reason for that is, if you think about this, if you look at the shape on the bottom there, the shape's a square. And so it's SS. So the perimeter is going to be S plus S plus S plus S, which is 4S. The height is S. So 4S times S is 4S squared. So the lateral surface area, if it's a cube, simplifies to just being 4 times the side length squared. Now the total surface area, you're going to have the 4S square, and then you're going to have the top rectangle, or the top square, which is going to have an area of S square, and the bottom square is going to also have an area of S square. So you're going to have 4S square plus 2S square, which is 6S square. Okay, and then the volume, you're going to have the area of the base which is S squared, times the altitude, which is S, and S squared times S is going to be S cubed. Okay, so really it's the same formulas, but it simplifies into more direct formulas. Okay, so example 3, find the lateral surface area, the total surface area, and the volume of the cubes. Okay, now again, I could do this problem the same way that we did these. I could find the perimeter of the base, I could find the area of the base, and then I could do the same exact thing we did up here. But when it's cubed, we have a simpler formula that we can use. So S, in this case, is 7 centimeters. Okay. So if I want to find the lateral surface area, that's 4 times S squared. So that's going to be 4 times 7 centimeters squared. Is that okay? Now 7 squared is 49, and 4 times 49 is 196. So this is 196, and we're finding area, so the units will be square centimeters. Or again, you can think about that. We have 7 centimeters square. So that's 7 centimeters times 7 centimeters. Centimeters times centimeters are going to be square centimeters. Okay. The total surface area, again, I could do it the way we did it up here, but I can also do it much more directly here since it's a cube. So that's just going to be 6 times S squared. So that's going to be 6 times 7 centimeters squared. And again, 7 squared is 49. 6 times 49 is 294. So we got 294 square centimeters. And then last but not least, the volume is just going to be S cubed. So in this case, that's 7 centimeters cubed. Well, 7 cubed is 343. So we get 343, and the units are going to be cubic centimeters. You with me on that? Centimeters times centimeters times centimeters, cubic centimeters. So the lateral surface area of this cube is 196 square centimeters. The total surface area, 294 square centimeters. The volume, 343 cubic centimeters. Piece of cake? I will go ahead and talk about converting here real quick, and then we'll call it the day. We won't actually do example 4 or 5 or anything. We'll start that next time. Okay. So in practical problems, it is often necessary to convert volume units from cubic inches or cubic feet to gallons or other units, including metric units. So we may need to convert like our 343 cubic centimeters. We may need to convert that to liters or gallons or something. Okay. We may need to convert our 2,688 meters into liters or gallons or whatever, and so on. Does that make sense? Okay. So the following conversion factors can be used to set up unity fractions like we've done earlier in the semester to be able to convert. Okay. So 1 cubic foot is equal to 1,728 cubic inches. And 1 cubic foot is the same as 7.45 gallons. So if you picture that, what's a cubic foot? A cubic foot is a cube that is 1 foot by 1 foot by 1 foot. You with me? And so if we had like a container that was 1 foot by 1 foot by 1 foot, it could hold about 7.5 gallons of liquid. Okay. 7.48 to be a little more precise. Okay. That's the same as 28.32 liters approximately, which is the same as about 0.0283 cubic meters. And if we're doing dry measurements, like measuring like beans or corn or something like that, that's about 0.806 bushels. Okay, does that make sense? So 1 cubic foot is about 0.8 of a bushel. Okay, about 80% of a bushel. Okay, 1 cubic yard is equal to 27 cubic feet. 1 cubic inch is equal to 16.39 cubic centimeters. 1 gallon is equal to 231 cubic inches. And 1 liter is equal to 1,000 milliliters or 1,000 cubic centimeters. So a cubic centimeter, sometimes that's abbreviated cc, is the same as a milliliter. Okay, so 1,000 cc's, 1,000 cubic centimeters is the same as 1,000 milliliters, which is the same as 1 liter. Okay, does that make sense? Okay, so if I wanted to know how many like liters would fit into this prism, okay, so like if this was a container, then I would need to convert the 2,688 cubic meters into liters. And I could set up unity fractions using these facts in order to be able to do that. Does that make sense? Okay. So again, we don't really have time to do that today. So I'm going to stop here. And so next time we'll pick up with the applications and we'll figure out, you know, like what's the volume, how many gallons could this hold if this is a pool, for example, and so on. Make sense? So next time we should get through the rest of this section. We'll likely also get through, if not all, we'll get through the majority of section 9.3, which is very, very similar, except we're going to be talking about cylinders. Okay, so a cylinder is like it's like a rectangular prism, except the bases are circles. Okay, but the way it's going to work is the same. Okay, so like if I want to find the lateral surface area, I'm going to find the circumference of the circle instead of the perimeter. Okay, does that make sense? Times the altitude. If I want to find the total surface area, it's going to be the lateral surface area plus the 2 circles area. Okay, and if I want to find the volume, I'm going to take the area of the circle times the height. So the formula is really the same. It's just that we're going to have circles involved because it's a cylinder. Does that make sense? Okay. See you next time. Have a good rest of your day.